Hi everybody, Mr. Farmer here, and today we're talking about oligopolies. Just like always, we want to first get those definitions down. So we're going to start with the definition of what an oligopoly is. Then we're going to talk about a thing called a concentration ratio, and a very similar thing called a Herfindahl Index. And last, we're going to finish up with game theory. There's lots of strategies you can be talking about, a lot of theories that go into this. We're going to stay very basic and talk about a thing called dominant strategy and a Nash Equilibrium. First off, let's review. Characteristics of few large producers. So the soda industry, Coke and Pepsi is a great example of that. Video game industry, PlayStation, Sony PlayStation, Microsoft Xbox, Nintendo, another good example of oligopolies. But this is where it can get a little confusing. In a pure monopoly, there was one producer. In a pure competition, there was a standardized product. In a monopolist competition, there was differentiated products. In an oligopoly, you have a few large producers, but then you can have a lot of other people also. But as long as those main top four have enough of a concentration ratio, which we'll talk about later, it's an oligopoly. So the number is not set. And as you can see, the products can be standardized or they can be differentiated. And so there's actually a lot of different variants within this. And so what we'll find out is people talk about oligopolies in different ways because there is no one set definition to them. It is pretty fluid for these things. So pricing. They do have control over pricing, but it's mutual interdependence. So what one firm does, because one firm or each of the major players has enough of the market power, they do influence the price. And so the others are dependent on that. They have to react to that. And that's going to play a role in some cases. So each firm is a price maker. But because mutual independence, you get this domino effect. If one person all prices low, everybody else is going to follow. If one person prices high, well, the others choose their price. So do they choose to go high or low? That's going to depend on the industry itself. So there's still barriers to entry, not quite as much as a pure monopoly, but still significant barriers to entry. Okay, it could be economies of scale. It could be large expenditure of capital, largest startup type scenarios, ownership or control of raw materials. Think about this. You have Samsung and Apple iPhone, who are two of the largest companies and manufacturers of smartphones. And then you have Google Pixel, which didn't do great. And the reason I bring this up is a company like Google, who is Google, struggled to get into the smartphone industry. That's how strong the barriers to entry are. A well-known company in the tech industry struggles. That's significant barriers to entry. Now, is there any particular reason why? It could be a lot of things. Ownership or control of the raw materials, large expenditure, a lot of the barriers that the monopolies have, but there is enough that other companies can get in there. So how are oligopolies created? It could be a lot of different things. In some cases, it's through mergers. Lots of smaller companies eventually merge together, and there just end up being 2, 3 major competitors after all the mergers are done. It could definitely happen this way. Is it always this way? No. Again, it's a pretty fluid definition, so there's lots of different ways that this thing can happen. But through mergers can definitely be one of those things, and that would be the horizontal mergers. Antitrust policies can get in the way and block these situations if it's seen that the merge of 2 or more companies endangers the consumers. Then the antitrust policies may or may not be enacted. Now, how do we figure these things out? Is it an oligopoly? What's going on here? So one of the things we look at is a thing called a concentration ratio. And this is you add up the market share of all the firms, the top 4 firms in the industry. Okay, it's a 4-firm concentration ratio. We just always use the top 4, but you can have a 5-firm concentration ratio also. It would just need to be declared. So what you do is you simply add that up, and according to some people, and the number we'll use is as long as those top 4 firms have a control of 40% or more of the entire market in whatever area you're talking about, it's an oligopoly. Now, is that 2 people, 3 people, 4 people? It could be a wide range. As long as those top 4 have 40%, there could be 100 other firms in there. It still meets that requirement. And this is when that inter-industry competition between 2 products associated with different industries, it can kind of skew that. And this is where that cross-elasticity, are they actually in the same industry? Are they not? This is where it gets very gray. Luckily, we get the benefit of saying, no, they're in industry A, B, C, whichever else. But reality is most big companies that can deal with these kinds of market shares, they dabble in lots of different things. And so it can be hard to figure these things out. We get to be in academia land, so we just get those numbers though. Very closely related, we have this thing called the Herfindahl Index. Here's why. There's a slight problem with that concentration ratio. What if I told you there's a concentration ratio, a 4-firm concentration ratio of 100? That means if I add up the top 4 firms together, their market share is 100%. But what's the makeup of those top 4 firms? Is it 1 firm plus 0 plus 0 plus 0? Well, that's still 100%. Or is it 4 firms, each with 25%? We don't know. That's where the Herfindahl Index comes in. Now again, for Herfindahl, we usually do the top 4 firms, but a lot of times the Herfindahl Index is actually, you square the market share of every firm in the industry. We do the top 4. And the reason why that's nice is, well, that tells you certain things. For example, if there's 1 firm in the industry, they have a 100% concentration ratio. 100 squared is 10,000. That's the highest Herfindahl Index. And so if you have a 10,000 Herfindahl Index, or HI, you're a pure monopoly. There's 1 firm and nobody else. If instead you have that 100% concentration ratio, but that's equally divided among all 4 firms, you get 2,500. So definitely still an oligopoly, but you know there's definitely more than 1 firm also. Now you can play around with the numbers and figure different things out. The main thing we want to know is the closer to 10,000, the more of a monopoly you are, and the further you are from that, the less of a monopoly you are. There are definitely some numbers you could throw around, statistics. We're not going to worry about that though. Last thing we're going to talk about is game theory. Okay, so game theory is the study of how people behave in strategic situations. It did start out in military, but then it quickly switched over to other different kinds of things. You can see chess is definitely on there, even football players are down there, but also in the business room. How do you react to decisions? Now in our setup, we're going to have 2 different players, and each of those players has 2 different choices. Now, again, people do think about it in chess, and you can look up game theory for chess if you like. And this is what it kind of is. You have a situation. You have 2 players. Again, we simplify and just do 2 players. You have player 1 and you have player 2. So player 1 over here, player 2 over here. And what they can do is they can choose which am I going to do. So player 1, trying to figure out, am I going to do strategy A or strategy B? And they make their decision. Then player 2 says, well, what am I going to do? Am I going to do A or B or A or B? Here's the thing though. Player 2 needs to make that choice of A and B before player 1 has made their choice of A or B. So if you're player 2, how do you make the choice? Because depending, your outcomes, seen over here, look different. So how do you make that choice? What theory, what strategy puts you in the best possible light to make sure you're in the best possible light. That's the core of game theory. How do you choose when you're actually unsure of what the other person's going to do? Well, for us, there's a couple of things. There's a thing called the dominant strategy. This is a strategy that is the best case scenario no matter what the other firm does. And if there is no dominant strategy, well, for us, at least one of the player will have a dominant strategy. If that isn't the case, I'll show you an example of that. In the absence of a dominant strategy, though, assuming one player does have a dominant strategy, then the other is going to make that decision based on the dominant strategy. So what is a dominant strategy? The best way to do this is through an example. So this is our typical setup, is we have a payoff matrix. This is the actual graph we use. It's a table, not a graph. And this is the typical way you look at it for oligopolies. So this is a famous one called a prisoner's dilemma. So prisoners are held in two separate rooms and cannot communicate. Both of you are suspected of a crime. You have two choices. You can either confess or you can deny. If prisoner A confesses, you're going to look at this column right here. Okay, and you're going to look at, you can notice how it's blue over here. So the person on the upper part is always the second set of numbers. And the person on the left, in this case prisoner B, is going to be the first set of numbers. So we're going to play a game called What If. For our purposes, we assume that prisoner A and prisoner B, they know all this information. They don't know what the other is going to choose, but they know the information. So if prisoner A confesses, prisoner B has a choice. They could confess. If they confess, they would get 3 years in prison. If they deny, they will get 10 years in prison. Which sounds better to you, spending 3 years in prison or 10 years? Let's assume 3 is the best choice for that. Next one, what if prisoner A instead denies? Well, if prisoner B confesses, then they go to 1 year. If prisoner B denies, again, we're going into this column right here because that's what we're talking about. We're saying if prisoner A denies, what's prisoner B going to do? So prisoner B, if they deny, they would get 2 years in prison. So 1 year or 2 year? 1 year sounds better. Okay. So what we find is this is called a dominant strategy. The dominant strategy for prisoner B is to confess. And the reason why is it's consistent. Regardless of what prisoner A does, prisoner B will always choose to confess doing this scenario. Now, if we did the other way, we'd find that prisoner A also has a dominant strategy of confessing because the numbers are the exact same. So the general outcome is that they're both going to confess using dominant strategy, which is regardless of the other person, they're going to stay the same. So, what's a dominant strategy? Well, again, we have a little bit different. This is now in the business world here. So we have firm A and firm B. Firm A can choose to invest or not invest. Firm B can invest and not invest. Now this one's a little bit different because of the setup. So firm B over here is going to be the second set of numbers. It's going to be this top part over here. And then it's going to be this top portion of the triangle over here. So if firm B invests, firm A could choose to invest and make $9, or do not invest, make $7. $9 sounds better. How about this next one? What if firm B instead denies? They do not invest. Well, firm A could invest and get $8 or not invest and get $11. Which one sounds better? Think about it for a second. Would you rather get $8 in income or $11? $11. So firm A does not have a consistent response. They are mutually interdependent. Depending on what firm B does, firm A chooses to invest or not invest. So they do not have a dominant strategy. So let's see what B would do. So we do the same thing. if firm A chooses to invest, we look at this top row, firm B can invest and get $10 or not invest and get 15. Which sounds better? The 15. If firm A, if they do not invest, firm B could choose to invest and get negative $10 or not invest and get $11. Okay, 11 sounds better. So firm B has a dominant strategy because again, they're consistent of not investing. So if you were firm A, what do you think you'd do? If you know all this information, you know firm B is going to not invest. And so if they're going to not invest, you're going to not invest. We already knew and saw that one. So this is going to be the logical outcome between these two players, is to not invest. That's the dominant strategy theory. Now there's a thing called Nash Equilibrium, and there's definitely lots of other places on YouTube that go through this. But here's how it works. Sometimes players have dominant strategies and sometimes they don't. Similarly, sometimes games have a thing called a Nash Equilibrium. Now, Nash Equilibrium is a concept where within game theory, where the optimal outcome of a game is where there's no incentive to deviate from their initial strategy. So, assuming you start in cell 1 of the 4 quadrants, is there any reason for either players to move any direction? If the answer is no, then you're in a Nash equilibrium. So for example, I already did this one, I already marked it up. So we have some examples here. So firm A, if they chose to invest, then firm B is going to invest, and so forth. So is there any reason why firm B would choose to not invest from here? Would they want to go from the 25 over to the 23? No, that's a bad choice. Is there any reason why firm A would want to go from investing to not investing? No, that's a bad choice. So in this case, if they'd started with invest and invest in this quadrant, they would stay there. There's no reason for one of them to deviate. This is a Nash equilibrium. In the same vein, is there any reason for them to go the other direction? Okay, well, if they choose to deviate, so they choose to deviate, so if firm A decides to not invest, they could always choose to go to invest, but again, they have to be in this do not invest quadrant. So they'd be going from 20 up to the 18. That's not good for A. How about for B? If they choose to invest instead, then they're choosing 15 versus the 12. Well, that doesn't sound good. So again, down here in this quadrant is another Nash equilibrium. So in this case, there are actually 2 Nash equilibriums. And that's just how you go about doing it. Is there a reason for somebody to deviate? If the answer is no, then that cell is a Nash equilibrium. So we went over the definition of oligopolies, concentration ratio, and Herfindahl Index, and finally game theory. Dominant strategy, Nash equilibrium. There's definitely more we could talk about. Are they allowed to collude, meaning work with each other? If so, then they'll be paying attention to, is there a place that gets me the best price? Maybe we'll all boost the prices up really high. Let's just not worry about antitrust law for a second. Okay, if we all boost up the prices, you might make out. Or is there no collusion? Well, that's what we're talking about. Hope that helped. Until next time, bye.